On today's episode of Teaching Mondays, what I would like to do is take you through the 6 stages of quality mathematics instruction. The 6 stages are pretty straightforward for every single mathematics lesson. What I want to do is take you through a task and really delineate them so you can have a great mathematics lesson also. The first stage is standard. The second stage is student learning outcome. Third stage is task selection. The fourth stage is task implementation. The fifth stage is task discourse, and the sixth stage is assessment. So I'm going to take you through each one of those and also use the task to set it up. If you use these 6 stages, it'll really help you strategically unpack and plan your mathematics lesson. And it also help you when you instruct the lesson because you have a framework to work with. So let's look at the very first one. Let's talk about something called standards. Every mathematics class, everybody has standards. Whether you use the Common Core or you use something else, you have standards. The standards are not going anywhere. We've always had standards, period. So let's not get in the conversation, the standards are not this, they're not that. Here's the reason a lot of people don't understand the standards. They really don't understand how they were developed. So I'm going to give you a hint. I want you to Google the words. I'm going to pull it up on the screen. Google the words Common Core Progression Documents. These documents take you through each of the content areas within the standards, and it's really going to help you unpack the progression of how you learn. For example, if it's operations in base 10, there's a progression document for that. It takes you through how students make sense of fractions, from the early stages to the latter stages. Each of these progression documents were made, and then they were spliced up based upon the grade level. That's how we got the standards. That simple. So when you read through these progression documents, it gives you an idea of not only what the students are coming into your class with, but what you're preparing them for. So coming back to the 6 stages of quality instruction, the first thing is standards. The standards define what students should understand and be able to do in the study of mathematics. Straightforward. I like the standards because they level the playing field. No matter where you're at, every student in the 5th grade has the same standards, 4th grade, etc. There's some nuances within the state standards, but big picture, it gives everyone the opportunity to learn the same type of material. Make sense? So when we think about the standard we're going to use today for this lesson is the 5th grade one. It goes back to my first video where we're dealing with fractions. Fractions is one of those topics that a lot of people are like, I don't know what to do with it. So we're going to unpack a fractions lesson for this video. So the standard is going to be use equivalent fractions as a strategy to add and subtract fractions. So the standard is given to us. Our job is to unpack that standard. Our job is to select rich tasks around that standard. And what's unique, even though you have the standard, you are allowed to pick what task you want to use to unpack it. That's the cool thing about it. So that's why a lot of people get it convoluted and messed up. The standards just give you overarching what do you need to do. How you do it is up to you. So we've given you the standard we're going to use for this video. And it gets a little bit more intent. You want to go a little deeper into the standard. It's solve word problems involving addition and subtraction of fractions. Okay? So we're going to be solving a word problem. Straightforward. The standards are not to trick anybody. They're literally just to give an overview and a guide. So as we think about that first stage as a standard, the second stage is the student learning outcome. The reason we have a student learning outcome is to ensure the discussion will be productive. Teachers need to have clear learning goals for what they're trying to accomplish. Yes, we have this big picture, overarching standard, but within that standard specifically, what are we trying to accomplish with this lesson? And it can't be they can add and subtract fractions. What does that mean? So when we think about a student learning outcome, think about specifically to the task that you're using, the lesson you're trying to unpack. What specifically is your learning target or learning outcome for that standard? In this case, for our example today, students will construct a valuable argument to defend their visual solution when adding and subtracting fractions. The main thing is they're going to construct a valuable argument to defend their visual solution. Now we know something specific that students are going to be doing over the course of the lesson. Now when I think about my assessment, I know specifically what I'm looking for. Can the student construct a viable argument? Did they have a visual solution? And as we stated prior, they're going to be adding and or subtracting fractions. And the thing this is important because a lot of times, especially when we're teaching fractions, everyone jumps to what's the formula? Do I find a common denominator? Do I keep, change, flip? Do I invert? What do I do? And the reason that's problematic is because when you start with the abstract, students don't have anything, they can't make sense of it. If you don't get the formula, you're lost. So what we want to do is think about the concrete representation of abstract. Think about how students learn. We want to start these fractions with the conceptual piece. Do they understand what really fractions are? Operations. Then we want to talk about the representational part and then the abstract. The abstract is the formula. I'm not saying the formulas are not important. I'm just saying we need to do concepts before procedures when it comes to fractions. So now, we've identified a standard. We've identified the student learning outcome. Let's think about task selection. According to Smith, Hennessy, and Silver and Stein, a mathematical task is defined as a mathematical problem or set of problems that address a related mathematical idea or concept. That's all the task is. It's just a mathematical problem or set of problems. The thing about tasks, not all tasks are created equally. I'm going to show you two tasks. Notice, these are what we call, you see a high-level task and a low-level task. One task is strictly focused on can you do a procedure, can you get an answer. The other task that you see is focused on some problem solving along the way. As you think about the standard, both meet the standard. But which task do you think is really going to engage students? Which tasks do you think is really going to give students the opportunity to make sense of fractions? Remember, all tasks are not created the same. And as we think about this thing called task selection, I'm not asking you to recreate the wheel. If you think back to our first video, Reverse Engineer, all of these tasks are already out there for you. I'm making a video in the future of different places you can find tasks, whether it's illustrative mathematics, whether it's Engage in Y, whether it's the National Council of Supervisors of Mathematics, whether it's your textbook. They're great tasks in the textbooks if you have one. Our job is to identify the great task and then use them. So don't think you have to go out and recreate the wheel and spend all night, how do I create a great task? They're already made for you for the standards. So don't go out and spend time, really spend time of selecting rich tasks. Spend more time doing that and not trying to recreate the task. What I'm going to do is show you 3 different word problems. All of these word problems meet the standard, but all of these word problems can engage students differently in the adding and subtracting of fractions using a visual solution. These are what we call problem types from cognitively guided instruction. So I want you to look at the screen. I'm going to give you a moment to look at the 3 tasks and pause your screen if you like. So as you look at them, think about the equation for the task, and I just want you to take a moment to think about how do you think students would solve them. So look at these 3 tasks and notice some differences and some similarities. So pause your screen as you look at it and read the task. Now, as you think about your selection of tasks, one of the big things we need to always think about, if we think about the concrete, representational, abstract, students use some manipulatives. Think about some manipulatives that can be used for this lesson. For this one, I recommend possibly putting out pattern blocks, possibly putting out fraction tiles for students to use. What manipulatives would you possibly use for students? And I'm not saying you have to use either one. I'm just giving you some ideas for fractions. So what manipulatives for this task would you possibly put out for your students to use and work with? And most importantly, why would you use those? Comment below in regards to manipulatives you would possibly put out for students to use to solve this particular task. And a lot of times we think we have to teach students how to use the manipulatives. You don't. Give them some time to explore. Students slowly make sense of the manipulatives for the task. One manipulative may not work. Think about the fractions and the values that you're using. Certain manipulatives may not work, but give kids a chance to explore that part of it. That helps them build that conceptual understanding and really making sense of the task and what it's asking. So now, we've taken you through the standard, taken you through a student learning outcome. I'll give you 3 tasks. All of those tasks meet the standard. As you notice, they're going to engage students in a different way. So you can identify which tasks you think you should use with your students. You may give them different tasks on a different day. You may want to use all 3. But think about the depth that you can go on with those tasks as opposed to earlier that basic rote routine task. So now we're at the implementation phase. This is the biggest phase. The reason being, research has shown that the implementation of tasks has the most significant impact on students. Let me read that again. This is from Boston 2012. The implementation of tasks has the most significant impact on student learning. The reason implementation is important, because think about it. If you start with a low-level task, the research shows us you're not going to take a rote routine task and make it high level through the course of instruction. It's going to typically stay low. But you can start with a high level task and it goes down through the course of instruction because you're pretty much spoon feeding them the entire task. What you want to do to keep it high, give them the rich task, then through your questioning, keep it at a high level. That way students are doing the grappling and the problem solving throughout the entire task. And that way you have a rich implementation and you can impact student learning. A couple quick steps, 4 quick steps for this whole process. Your goal is through task implementation. You pose this rich task to students. Make sure they have a big picture understanding. That's like your first step. Second, let students individually work on the task. The key is to have a task with multiple entry points, multiple ways they can possibly solve the problem. That way, every student, regardless of their ability, can have an attempt at the problem. So think back to the task that I showed you earlier. Then what I do is, I do something called a turn and talk. So students are working individually. I give them sufficient time to come up with some strategy or some way to solve it. I let them turn and talk to the neighbor or small group. Then I let the group turn and work together. All during this time, I'm circulating and asking questions. This is giving me a feel for how individually students are working on a task and making sense. In their groups, how are they making sense of the task? And then I'm bringing back whole group. And we have a whole big group discussion in regards to the task. Simple formula. There's no trick. There's no magic pill. It's literally giving kids time to make sense of it. And during the sense-making time, we have to think about the discourse surrounding it. When we think to this, Boston 2012, she says it best. Engaging in a mathematical discussion following their work on an instructional task influences students' opportunities to engage in high-level thinking and reasoning. We got to give them time to talk. I've never met a kid who did not like talking. Never. The key is making sure the context is rich for them to talk about math and think about making sure the context is engaging to them. I just gave you a sample word problem to work on. You can change the context based upon your students. So that's the beauty of mathematics. Like, think about what your students like. And then as we think about it, what I want you to do when you think about your discourse, think about the 4 question types. This is taken from Principles to Action, who got it from Bowler and Brody. We're going to look at 4 question types. You have your gathering information questions. They're focused on students recall of facts, definitions of procedures. Those are your basic questions that you ask. What did you do? Then you have your question type 2, probing thinking. These are where students are going to explain, elaborate, or clarify their thinking. This is starting to get them at a deeper level of thinking of what they're doing. So not just telling you what they're doing, but giving you some rationale behind why they're doing it. Then the third question type is making the mathematics visible. Students discuss mathematical structures and make connections. So you think about that small group work. Start letting students see, compare, and contrast to their neighbor. What did you do? What did you do? Why did you do it? Could we have done it differently? And then start making some connections to possibly the real world. Then that's going to build upon that repertoire of questions that you're asking. So you think about, you've asked them what they did, why they did it. Now you're giving them some ration, making them think about the connections for what they're doing and why. And then the 4th question type, encouraging reflection and justification. You want students to have a deeper understanding of the mathematics that they're involved in. Go beyond just can they get an answer, but can they truly do some sense making in regards to the problem that you've given them. These are just 4 question types. What are my basic questions in the classroom are, what did you do? Why did you do it? Those are like my entry point questions. Then I follow up, could you do it a different way? What if you did this? Comment below, what are some questions that you like to ask of your students? What are like your go-to questions? And not your yes and no questions, but what are some of your go-to questions to ask of students when you're teaching mathematics lesson? So now, as we think about this lesson, we start off with a standard. We looked at the student learning outcome. We then talked about what is our task that we've selected. We've talked about the task implementation. We've talked about the task discourse. The last piece is assessment. How are you going to assess the task that you're giving the students? Why is this critical? Think back to earlier. Earlier we talked about the student learning outcome. This should tell us, did they meet that student learning outcome? And this assessment is based upon how they performed as related to the task, not how they behaved, not how they looked. It's specifically to the mathematics. So here's a rubric that we use in regards to assessing student learning. Basic rubric, very basic rubric. It looks at you either got it, you're getting it, not yet, or not enough. Straightforward. It's not you got this wrong or you don't know how to add fractions. It gives a student an idea of where they're at. And obviously I can give them more specific feedback and elaborate upon the feedback that I'm giving them. But at least this gives them an idea. A lot of times we say you got an 80%. What the heck does an 80 mean? You got a 70. What does that mean? This tells them specifically how they're doing the task. It also helps communicate with parents. How is a child doing with the task? This summer, we're going to release a new book that's going to go deeper into assessment and how this connects to a bigger picture of assessment in regards to the standardized assessment, because everything should connect and flow when it comes to a mathematics lesson. It should be a nice flow, not disjointed. Everything should make sense to everybody involved and all stakeholders. So as you think about the 6 stages of quality instruction, what I want you to do is comment below. What are your thoughts? Do you like it? Do you not like it? Do you have questions about it? Would you do something different with it? Also, if you've used something similar, let's talk about that below in the comments. Let's have a full-fledged discussion about how can you use this in your classroom environment, and especially if you want to go in deeper into the task selection. That's a new video we're going to come out with later. I'm going to do another video where we talk about the implementation of tasks. Definitely doing the video, especially around the time the book drops this summer, about the assessment piece. But the goal of this series is to help teachers improve in regards to mathematics instruction. It's not to withhold information like, hey, I know a lot of people are like, what do I do? How do I do it? That's the purpose of these videos. So if you have ideas for future videos, if there's something specifically you want seen or done in the video, ask. I'm going to leave you with this challenge. I want you to try implementing a rich problem-solving task with your students and let them explore. And let me know how it goes. That's the big thing. Think about getting out that rote routine task I showed you earlier. What's a rich problem-solving task you can implement with your students? And then let me know how it goes. Until next time.
It's a new day.